Hello, Algebra 1. Today we're going to start Chapter 8. And Chapter 8 is all about more ways to solve quadratics. And so far we've solved quadratics technically by graphing and also by factoring, but we're going to learn that there's a few other methods to use, which is pretty cool. Actually, I think 4 different methods. But before we get to that, we are going to be asked to get some exact answers that we've never gotten before. We're going to be asked to simplify radicals, mostly using the product property technically. Okay, so they mention here that if you have a square root and there's 2 numbers multiplying together, you can split it up. You can also bring it back together. So if you have square root of 3 times square root of 5, those can simplify to make square root of 15 if you wanted. Well, this is the secret behind how I'm going to teach you how to simplify square roots. Now, before we get to simplifying square roots, it might be helpful to talk about perfect squares. Perfect squares, so that's on the back. We'll make a list. Perfect squares are numbers whose square roots are whole numbers. So, and we can make a list by just taking, starting at 0 and counting up and squaring numbers. When you square them, you're going to get a perfect square. So 0 squared is 0. 0 is a perfect square. It's just not that helpful, I guess. 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. 3 times 3 is 9. 9's a perfect square. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 36 is a perfect square. The square root of 36 is 6. The square root of 25 is 5. So these come out nice when you square root them. You're going to have 49. You're going to have 64. You're going to have 81. 10 times 10 is 100. 11 times 11 is 121, excuse me. 12 times 12 is 144. And we'll stop at 13 times 13 is 169. If you are asked, oh, it's a little blurry, isn't it? If you are asked, there we go, okay. If you are asked to find perfect squares, a lot of times you're going to have a perfect square and it's going to be a nice answer. Square root of 121 is 11 and you're done. But there's a lot of numbers in between these perfect squares, isn't there? Well, what we're going to learn today is how to simplify those as well, okay? So let's get a little bit of vocabulary down first. If you have the square root of 28, it turns out that this radical symbol can have a lot of different numbers here, but if nothing's written there, it's actually got, it's called the index. It's actually got an index of 2. If nothing's written, the index is 2. But it's very common to have indices of 3, 4, etc. You can put any number there. You could even put a fraction there, technically. And so the index goes there. This is called a radicand. So yeah, the number underneath is called a radicand. And together, this whole thing's called a radical. Well, what I like to do is I like to simplify radicals by doing a factor tree. I just ask myself, well, what are some 2 numbers that multiply together to make 28? And a lot of people go, well, if it's an even number, it's divisible by 2. And that's fine. You can totally go that way. And then 14 is divisible by 2. And then 7 is prime. It doesn't break down. Well, class, what you're going to do today is you're going to look for pairs of numbers. Now, why are you going to do that? Well, pairs of numbers always multiply together to make perfect squares. 2 times 2 is 4. The square root of 4 is 2. We're going to evaluate the square root of 2 times 2 and get 2, but left over is a 7. So the simplified version of square root of 28 is 2 square root 7. Now, as you get to recognize perfect squares, you might approach this question a little bit differently. You're going to think, what are some perfect squares that go into 28? And you're like, wait a second, 4 goes into 28. 4 is a perfect square. 4 times 7. What's the square root of 4? 2. And you're done. 2 square root 7. Now, what happens is things that are left out, things that come out, they're going to all multiply together because we're doing factor trees. It's all multiplying. Things that are left on the inside are going to multiply together because, again, we're doing a factor tree. So on A, let's take a look. It's 108. We could try to think of some perfect squares that go into it. But, oh yeah, we could do... I think I'm seeing it. Yeah, it turns out. Okay, so I'll just give you guys a heads up. 36 goes into this. That would be the quickest way to do this problem, is to set it up as 36 times 3, and you're going to be done super quick. But I don't think many of us would see that yet because we're new to this. So we might start really basic and say 2 and 54. And then go from there, 2 and 27, and go from there 3 and 9. Now you might recognize 9 as a perfect square, but let's say you don't. 3 and 3. Pairs of numbers are perfect squares, and they come out. Pair of 2s, a pair of 3s. So a 2 comes out. Square root of 2 times 2 is 2. Square root of 3 times 3 is 3. They're going to multiply together. And left over and didn't break down was a 3. So our final answer is 6 square root 3, which, class, is exactly what you would have gotten had you broken it up as 36 times 3, because the square root of 36 is 6. All right, let's try another one. 24. Well, class, if I was to do this the quickest way possible, I would do 4 and 6 because 4 is a perfect square. And my answer would be 2 square root of 6. But we're new to this. Let's break down 4 into 2 and 2. We did have a pair. Let's break 6 down to 2 and 3. Nope, no pairs in there. The pair, square root of 2 times 2 is 2. But then what's left over is a 2 and a 3. They multiply back together to make 6. You can have negatives going on, so we got this negative out front. 80, the way I'm seeing it is 8 and 10. That's the way I'm seeing it. 8's 4 and 2. Oh, 4 is a perfect square. 10 is 5 and 2. Oh, check it out. We got a pair of 2's here, but we also have a pair of 2's there. So what we're going to have is negative out front, 2 times 2, square root of 5. 5's left over and it didn't break down. So our final answer is negative 4 square root of 5. So in hindsight, if I square 4, I get 16. I could have done 16 times 5. That would have been the quickest way to do this problem, but I didn't recognize it. Yeah, I didn't see it. All right, 5 square root of 75. Take a look. 75. Oh, if it ends in 5, you know 5 goes into it. So let's do 75 divided by 5 is 15. 15 breaks up into 3 and 5. We got a pair of 5s. Now notice we got a 5 that's already waiting. So let's write that 5 down. But we got another 5 that's going to join it. And we got a 3 that's left over. So we get 25 square root of 3. So if there's a number out there already, it's just going to multiply with whatever else comes out. Quickest way to do this problem is make it 36 and 2. What's the square root of 36? 6. 6 times 3 is 18. Square root of 2. But listen, class, you could totally do factor trees and see what comes out. All right. Practice, practice, practice. Have a good day.